Welcome back, everyone. Identify the hybridizations as well as approximate bond angles in these molecules. We're given two examples and we can begin with the first one, methane, CH₄. We have to recall for simplicity that carbon has a valency of 4, which means that carbon can make 4 bonds based on the octet rule, and basically carbon must be the central atom bonded to 4 hydrogen atoms. Hydrogen atoms essentially make only one bond, so this is a feasible structure. So we have our first structure, and now for B, we're given boron trifluoride. Boron belongs to group 3A, and essentially, as opposed to the octet rule, boron will contain a total of 3 bonds in its neutral form, similar to aluminum. Therefore, boron is bonded to 3 fluorine atoms. They are our terminal atoms, right? And essentially, we have our structures. Now, from here, we want to determine hybridizations. And starting with A, we have to recall that hybridization can be obtained from the steric number. So for A and B, we want to determine the steric number to begin with, which essentially means that we want to count the electron regions around each central atom. For A, that would be carbon. For B, that would be boron. Now, for methane, we notice that we are given 4 carbon-hydrogen bonds, and those are all individual electron regions. So steric number for A would be 4, and for B, that would be 3, right? Because we have 3 boron-fluorine bonds. Based on steric number, we can determine hybridization. We have to recall that steric number of 4 means that hybridization is sp3, s1p3, right? 1 plus 3 equals 4, so that's very easy to remember. And now, if steric number is equal to 3, we will have s1p2, right? Or basically sp2. And those hybridizations, according to the BF₃ theory, also correspond to specific bond angles. sp3 means that we have tetrahedral geometry with bond angles of approximately 109.5 degrees, and sp2 corresponds to trigonal planar geometry with bond angles of 120 degrees. So those would be our answers. Thank you for watching.